So, welcome back. I defined for you the angular velocity and its relation with the linear velocity. In order to explain what is happening in the case of the rotation of a rigid body about an axis, and the axis chosen here is the z-axis. Of course, I told you that in time delta t there is a change in the angle delta theta. So delta theta is equal to, therefore, being proportional to delta t, this is equal to a constant times delta t, and this constant we have learned before in the case of circular motion. So we find that in the limiting case that delta t tends to 0, this omega turns out to be equal to the time derivative of theta, d theta or dt. And as we established before, we find that the velocity of the particle under circular motion about a center, which I have shown over here, is equal to omega r. Now omega d theta dt is true for all particles which are participating in this kind of a rotatory motion, and I said that for any particle which is at a distance ri from the center of the circle in which it is moving, the circle of course is perpendicular, or this axis is normal to the circle in which the motion is taking place, and the rotation carries on. So I need an axis, and about that axis I have a rotation and a circular motion which will happen. Okay. So anyway, so far we have treated this omega as defined in this case as a scalar quantity. But today we will discuss omega as a vector quantity. And as I told you, the vector quantity can be defined all by itself, can be obtained by multiplying a defined vector quantity by a scalar. A scalar multiplying a vector gives rise to a new vector, or a new vector can be obtained by the cross product of two vectors. When the new vector is in a direction which is perpendicular to both the vectors, okay, A and B for example, and I said that there could be two cases. In one case, the new vector could be towards us, out of the page that you are writing on, or out of the board that I have over here. This is what I did show to you, that it is the right hand palm and the curl of the fingers. This is how vector goes, and the resultant vector points in the direction of the outstretched thumb. Or in another case, again the same exercise I do, but the outstretched thumb now enters into the board or the page that you have, and this is about the direction of the new vector. Okay, so we'll just discuss in a little bit more details about this omega, the angular velocity for a situation like that. So let us discuss this relation for the ith particle or ith mass in the system. Vi is equal to omega ri. We can see from here that for particles or masses on the axis of rotation, r is equal to 0. So v is equal to omega r is equal to 0. So the velocity of the particle, the linear velocity associated with the particle, will be equal to 0. What that means? That means that the masses are particles on the axis are stationary. They are stationary. They are not moving. Which is also a verification that the axis is fixed. Okay, we have the axis fixed. The other thing which we observe is that the angular velocity omega is the same for all particles. It's the same for all particles, for all the masses which are participating in the motion of rotation. So we find that omega is the angular velocity of the whole body, the entire body under rotation. And then we make a couple of observations. One, that in pure translation, all constituent masses have the same linear velocity. Same linear velocity. At any instant, given instant of time, we have the same linear velocity. At a given t, whatever, t may change, but the angular velocity will be the same. It is rather independent of the time t. Similarly, in case of pure rotation, all constituent particles masses have the same angular velocity. Same angular velocity omega at any defined instant of time. So that is also independent of the time. Now, if I translate the motion of a given particle, here is the center C, and this is the point under consideration, I can call it P. This is the center C, and this is the plane which is perpendicular to or normal to the given axis. Then in that case, we observe the following, that each particle of the body moves in a circle. Maybe the radius of circle is equal to 0 if the particle is lying on that axis. Second point about this is that the circle lies in the plane which is perpendicular. This is the symbol of perpendicular to the axis. And the third observation is, which we should bear in mind for all discussions that will follow, that center of the circle is on the axis. So far so good. Omega was taken as a scalar quantity, doesn't matter. But now, in the next few moments, we are going to show that omega is a vector. How we obtain that omega along the fixed z axis which is there is a cross product of two vectors. So here we redraw the diagram that we had, and this is basically a circle perpendicular to this direction z, and the same axis x, y, z we have taken the cue from the last drawing, and we find that this is the origin of the coordinate system x, y, z. Okay, and this is z axis about which the rotation is taking place. I have just taken a representative circle over here. The circle is not so good, the drawing is not rather poor, but we are taking a point P under consideration which is going in this on this circular path. Okay, and this is the position vector r which corresponds to P, we find, and we have discussed, that the vector omega will be in the direction of the axis, in the positive direction of the z-axis as we have defined. It could be any axis, x, y, like we have chosen z-axis over here. Okay, so we find that the omega is in this direction, okay, and the r is like this, and there is a vector which has to be perpendicular to the r vector and to also the omega vector, because we are going to talk about a cross product of two vectors. As I said, that a vector A cross B in the definition is equal to a new vector C such that C dot A, that is the angle between the two of them, this defines that the angle between the two of them is 90 degrees. So this is equal to C dot B also, C dot B, or the converse of it, B dot C, this is equal to 0, and the angle theta in that case is 90 degrees. Okay, so this is the definition that was given for the vector or cross product of any two vectors. So here we have omega, the angular velocity, cross r. Now look here, r is this vector coming from here to the point P. Okay, now I can split this vector into two parts. One is OC plus CP by the laws of vector addition. The unwritten lies that they should be of the same variety, and so they are of the same variety, their lengths, and we have split it in two parts, and we see that for r I can write OC plus CP, vector OC plus vector CP. But we find that this vector OC and the vector omega, they are in the same direction. So they make an angle of 0 degrees, and sine of 0 degrees is equal to 0. Therefore, this, the first part of it, when I split it, omega cross OC, that is equal to 0. So we are left with omega cross CP. Okay. So omega cross r is equal to omega cross CP. This is one result we obtain, and then it shows that this omega cross r will be perpendicular because of this property to both the vectors omega also r. Okay, and r here has been taken as equivalent to CP. So omega cross r, the magnitude of omega cross r will turn out to be, if I write this vector, the magnitude of this, even if we take this as a vector quantity, it doesn't matter. Okay, this I have already taken as OC as a vector quantity. Okay, but it has a magnitude equal to r perpendicular. So I just write that omega cross r, the magnitude of it will be equal to omega into r perpendicular, and the direction will be perpendicular to this also this, which turns out to be the tangent to the circle. And we know from before that the tangent to the circle is also the direction of the linear velocity v. So I can write my result for v as V can be defined, the translation velocity is equal to angular velocity cross r, and the direction vector or the unit vector v cap and this vector's cap, they will be equivalent to each other in the same direction. So I can write. Now two observations. In the system that we are defining, omega cap, the direction of omega will not depend upon the time t when it is happening there. It's not a function of the time. That means the direction remains unchanged. If it is in the z plus direction, it will remain in the z plus direction. However, the magnitude of omega may be a function of time, but the direction of omega will remain unchanged. So, however, for complex rotation, if there is some complexity in the rotation, and for example there is a precession or some kind of a thing which is happening, which you must have seen in the tops when they are going around. So for complex rotational cases, which will not deal at this stage, even the direction of the omega may become a function of time, as also the magnitude is also a function of time. Now we have introduced omega as a cross product of two vectors. Cross product of two vectors, and we have found that the velocity vector is given like this. So omega is also a cross product. Omega cross also gives rise to a cross product. We can get the velocity here, and as we have been doing, if we get the velocity, then we can define the angular acceleration, which is equal to d dt of omega, the angular velocity, and the angular acceleration, and thereafter I talk about the counterpart of the linear motion for force, which will have the torque and angular momentum, etc., etc. Okay, L as a vector, alpha as a vector, torque, tau as a vector, which is similar to the force, the angular the linear momentum, the counterparts for the linear momentum, the linear acceleration, and the force. They are there. This is the angular momentum, this is the angular acceleration, and this is the torque. We'll talk about these things, okay, and I expect that you be prepared for my next lecture, where I make combination of all these things and obtain it for a particular case and then for a system of particles. Okay, so long. I have enjoyed, hope you enjoy, and remember that you are not questioning me, so how can I answer? So if you question, I will answer. If you are confused, I will be happy. Thank you very much.